So this is joint work with Anthony, Andrew Clark, and Gottlieb D'Ambrosio, and I'm going to talk today about the link between mental health and pension reform in the UK. And the thing that might sound already a bit more foreign to you, perhaps, is that we're going to look into some biological differences and looking into heterogeneity by our own DNA. So let me first start by, the usual slide that I have here for economists in the room. So why should we care about mental health? Well, usually the points I make are two. The first one is its incidence, so it's quite incident, and the mental ill health is quite costly as well. So this is some of the reasons why we should care, if anything. On top of that, so we know that there's a lot of work on the determinants of well-being, determinants of mental health among others by people in this room. And some of the things that are recently coming across the literature is that part of well-being and part of mental health can be predicted by our own DNA. So the DNA we're born with will predict to a certain extent the probability we'll have to suffer from poorer mental health or to enjoy a better well-being over our lives. So just to give you a bit of an intuition here, I don't want to get into the details, but we can talk about it later if you're interested. There's still some debate in the literature about what's the proportion of a given behavioral trait like education, income, or well-being that can be predicted by our own DNA. But what I'd like you to think of is that this proportion is not large enough at all to be able to claim some sort of genetic determinism. So what we are, what we achieve is not really determined in any way by our genes, but genes are still quite predictive in a way that is still of interest for us social scientists, but because their predictive power is comparable to the predictive power of many socio-demographic characteristics that we tend to observe when looking at these variables. So what we do in this paper in a nutshell here is really trying to understand what are the mental health effects of a pension reform in the UK, and in particular ask ourselves whether these effects are moderated in any way by our own genetic endowments, and in particular by our own genetic predisposition to be more or less depressed. So this is what in the jargon is called a gene-environment interaction study. It basically is simply looking at the effect of an exposure, in this case a pension reform, on a given outcome, in this case depression, and we're simply looking for treatment effect heterogeneity here. So in this case, the heterogeneity, the moderator that we're looking for is our own propensity to be more or less depressed. So what do we find in this paper in a nutshell? We are using, again, for the third time today, data from the UK HLS. So we're all very familiar with that. And we find that, first of all, on average, postponing retirement age has adverse mental health consequences for individuals who are affected by these sort of reforms. However, when we dig into heterogeneity, we find that the effect is only there, the adverse mental health effect is only there for individuals who are, to begin with, already more predisposed to suffer from mental ill health. We interpret this result as a sort of evidence that there's some unequal consequences of this sort of policy in the context that we observe, because we have mental health inequalities that already exist because we are different in terms of DNA that are exacerbated by this particular reform. So as policymakers, we might want to think of what reforms reduce or at the contrary exacerbate mental health inequalities in this case, but in general inequalities that stem from differences that are beyond the control of individuals. And last but not least, we additionally find that the reform had negative spillovers onto physical health that were again more prevalent for individuals with a higher genetic predisposition to suffer from mental ill health. Okay, so this is really the paper in a nutshell, but how do we get there? I'm going to talk a little bit about the institutional framework of this reform in the UK. Then I'm going to walk you through the data, empirical strategy, and show you quickly some results. Okay, so the institutional framework. Let me start by saying that the retirement age in the UK has been remarkably stable for half of the past century, basically. So it was set until 2010 to be 60 years of age. And of course, like in many other OECD countries, there's financial incentives for staying longer in the labor market, but about 95% of women tend to retire the earliest they can, which is consistent with other figures from other countries. In 1995, the government emanated the Pension Act with the objective of progressively increasing early retirement age for women from 60 to 65 years of age to match the retirement age of men, which was already set at 65 years of age. And this 5-year increase was going to happen in a 10-year time span. Then another reform actually happened meanwhile. So the increase had to speed up a little bit, but that was the objective to begin with. Daddy has to go. Yeah. So what does this mean in practice is that take two women that are born 2 months apart. If they're affected by this reform, one of them, the youngest one, will retire 1 month later than the oldest one. So we're not the first to observe what are the consequences of this reform. There's been already some work looking at this. The first and foremost, other scholars have asked themselves whether we find the expected effect of the reform on the labor market, first of all. So they do find that women who were subject to this delay in retirement age stayed longer in the labor market. They had a higher employment probability, lower retirement probability, higher probability of being out of the labor market, by the way. So that's already, first stage of the reform is there. So something happened in the labor market as one would expect. More interestingly for us, there's already some evidence pointing towards a mental health effect. And this in the sense that this paper by Carino and co-authors and Della Giusta and Longhi find that the reform somewhat affected subjective well-being by decreasing it, and the women affected by the reform also reported higher depressive symptoms for the GHQ-12 questionnaire. Okay, so before I get to the result, how are we able to observe all these beautiful things and genetic data at the same time? Well, the answer is always the UK causal longitudinal study. So if you're not using it already in your research, I guess that's yet another incentive to do so. So you know already about this data, but what's really of interest for us here is that we have some quite detailed health information on participants, and it's not just subjective measures of health, but we also have some somewhat objective measures of health, and I'm making some air quotes here because they're still self-reported, so we're not linking administrative data, but we're asking individuals if they've ever been diagnosed by a doctor with a set of conditions, including depression. And the second main thing that is really of interest for us is that about 10,000 UK HLS participants have agreed to have their DNA genotyped, which means basically that they had blood samples drawn, and we were able. I'm including myself there, but it's mostly people at UK HLS. We're able to extract about 100,000 common genetic variants from these biological samples. And what we can do with these genetic variants is we can use them to build something called a polygenic score. So what is a polygenic score? Just to give you a quick intuition, is you can take it as a sort of index or a measure of your genetic predisposition over your lifetime to be more or less depressed in this case. But there are polygenic scores for educational attainment and other behavioral traits. And you can see, for instance, the one for educational attainment can predict now up to 16% of your educational attainment over your lifetime. So they're quite predictive things. For mental health, the number is a bit lower. It's around 9%. Okay, so this is all you need to know about polygenic score for the sake of this presentation, but just to give a bit more details, and then you can zone out for the next 2 minutes. As with any predictive exercise, we have 2 phases. We have a discovery phase and a prediction phase. So the discovery phase, we don't really do it ourselves, in the sense that it's the literature that tells us which genetic variants in our DNA correlate with a given trait. And here we're relying on the study, on the genome-wide association study by Patrick Turley and co-authors in 2018, and they discovered that 248 genetic variants in our DNA display significant associations with depressive symptoms. So what we do is we take in the UKHLS database these 248 genetic variants, and we use them as a measure, like as ingredients to put in our polygenic risk score. And this polygenic score is nothing other than a weighted sum of all these genetic variants per individual, and the weights are the betas, the associations found in the discovery study that tell us in a way the relative importance that each of these genetic variants plays in predicting mental health. Okay, parentheses closed. Okay, we have our reform, we have our mediator. So what is the outcome of interest? Here we look at depression, but I've not been precise what I mean by depression. We're particularly interested in diagnosis of depression. This is because there's already some work on well-being and reported symptoms of mental health. So we wanted to understand really if this translates into higher actual diagnosis of depressive symptoms. So the question is, in the questionnaire is phrased as, since the last interview, has a doctor or other health professional newly diagnosed you as having one of the following conditions? And it's followed by a list of like 18 items. And the only mental health items we have is depression. So we take depression. Just some summary statistics here. The incidence of depression in any given wave for women in the UKHLS is between 1% and 3%. And about 13% of women in the genetic sample of the UKHLS have been diagnosed with depression at least once. Okay, so the first thing we wanted to understand is, first of all, is the polygenic score that we measured, that we computed, really predictive of depression, or is it not? And this is an open question because the associations were discovered in different samples, so now we're really testing whether this association exists in the UKHLS. And it seems to be, something seems to be there. So individuals that were ever diagnosed with depression seem to have a distribution of this polygenic score that is somewhat to the right as compared to individuals that were never diagnosed with depression. And at the same time, when we plot a linear association between the polygenic score for depression and the incidence of diagnosis of depression, we have a positive association going on there. So how do we, now that we have all the ingredients and we know that the polygenic score is associated with depression as it should be, how do we get to our identification strategy? So basically all the black terms in this equation are something that's already been done in the literature. So we're just taking what the other studies have done and analyzing the effect of this reform in the same way. And if you just focus on the black terms, basically the coefficient of interest in this regression is alpha 1. Alpha 1, you can take it as the coefficient attached to a sort of treat-time post-dummy in a difference in different scenario. And you can interpret it as a treatment effect in a sort of unbiased way. And the reason why we can do that is because this is a free-way fixed effect regression. We're controlling for, sorry, is there a pointer or not? Okay, I cannot do it. I'm sorry. Okay. We have, we're controlling for quarter of interview fixed effects, cohort fixed effects, and age fixed effect at the same time. So this is the free-way fixed effect scenario, so that any differences in the eligibility status to the reform is arguably random. Okay, so what we do on top of what's already done before, we augment the specification with the terms that are colorful. So first of all, the interaction term between the reform and the polygenic score for depression. We, of course, control for the polygenic score on its own, and we control for some technical variability that you don't need to know right now. We also have some regular control. We have region, household size, education, marital status, household tenure, and the number of employed people in the household. And we estimate this regression with pooled OLS. We are using individuals in a sort of cross-sectional way. So we're clustering in standard errors at the individual level because it would be a bit too demanding if we were to use individual fixed effects here. So just a word about the estimation samples. We have to make some restrictions because of the reform specifics. So individuals in our sample are born between 1949 and 1953 and are between the ages of 59 and 62 by the time we observe them. And we're also focusing on white women only. And the reason we do that is because when we're talking about genetic data, it's always quite a sensitive topic to focus on single population groups. Unfortunately, so far, the amount of research that has been done is mostly focusing on Caucasian populations. But we don't want to confound any differences in ancestries that correlate with difference in cultural practices in what we're doing here. So we only focus on white women for this reason. Okay, so up to the results. Oh, I still have some time. Okay, so before getting into the mental health results, we wanted to make sure that in our small sample of 1,500 women, 1,000 would have been very good, but no. In our small sample, if first of all, the first stage of the reform works somehow. So if there is any employment effect of the reform, and we're very reassured to see that there is. So both with and without controls, and something that we wanted to check actually is what happens when we interact the reform with the polygenic score for depression. Was there a different reactivity to the reform based on genetic predisposition to be more or less depressed? And the answer is there doesn't seem to be. You may argue that this is just a lack of statistical power, so that this minus something is actually a minus something rather than a zero, but we can discuss it later, but it's more of a zero when we do multinomial logic regressions, and we try to treat this a bit better than just with a linear probability model. Okay, so now that we know that everything went as it should have in the labor market, is there any effect on mental health? And the answer is, yeah. There is something that gets a bit more precise when we include individual controls, but there might be something, might be just a question of power. What's more interesting for us is that as soon as we divide the effect of the reform between the average effect, and then the effect for someone with a 1 standard deviation higher polygenic score for depression, meaning that someone with a higher predisposition of getting depressed, the effects is really driven by these people. So the idea here is that 1 standard deviation higher polygenic score for depression increases your likelihood of being diagnosed with depression by 1.3 percentage points, which is quite large considering the average numbers in our data. Okay, so this is the main result, the main takeaway of the paper. We do a bunch of robustness checks to make sure that this is correct. We also do a bunch of work with the other labor force statuses. We do also falsification tests because men were not affected by the reform at the same time, so consistently we don't find an effect for men. We also find that the effect is somewhat persistent over time, so it's not just in the year you're affected by the reform, but also in the up to 2 years after the reform. Okay, and before at some point we're like, okay, so what? What if you're feeling more depressed? What happens to your life after that? And we've thought, is depression somewhat linked also to worse physical health in general? And in the data, we have some variables on other physical health diagnoses. And we just wondered what happened to physical health, especially for these women who were most affected by the reform in terms of mental health. So we have a list of like 18 different items, so we didn't want to run 18 different regressions, so we summed them up together, and we look at the probability of being diagnosed with at least one physical health condition. This could be angina, diabetes, cancer, anything of the sort. And then we look at the number of other conditions. And what we see is that the average effect of the reform is null mostly. But then again, for women with a higher than average polygenic score for depression, there seems to be a positive effect of the reform on these variables, meaning that these women not only suffer worse mental health as a consequence of the reform, but they also suffer from worse physical health conditions. So this is very aggregate in a way. So we try to dig a little bit more into what is really driving this association here. And we use a data-driven approach that categorizes all the other physical health condition into some sort of organ system function, if you want. So we have some here at the top, we have like some heart condition, lungs condition, brain diseases, thyroid diseases, or other. And what we see here is that the results seem to be mostly driven by respiratory conditions. We're quite puzzled by this result, so we try to understand what's going on here. It could be the case that this is simply driven by the fact that the genetic variants that we're using that predicts depression, they also end up predicting some lung disease. That could be an option. Another option could be that what we're actually observing is, and I think this was our working hypothesis in a way, is somewhat mediated by the worsening in mental health. And we know that there's a direct biological link between respiratory diseases and mental health. This is because mental ill health causes oxidative stress, and oxidative stress can increase the likelihood of having a respiratory disease. It could also go through another channel, such as somatization, whereby any repressed emotion that you may have are rechanneled into physical health symptoms. So we test this hypothesis. How do we do that? We control in our regression for first polygenic score for respiratory diseases. Then we try to see if it's mediated by mental health by controlling for mental health directly. So the outcome that we used before, there was just the diagnosis. And then we try to expand the definition of mental health, not just focusing on diagnosis, but also focusing on self-reported symptoms of mental ill health. And what we see is that it doesn't really seem to be, the relationship doesn't really seem to be driven by common genetic variants, but as we control for depressive symptoms and both in terms of diagnosis and self-reported, we see that the effects kind of converges towards zero. So you can take it or leave it, take it with a big pinch of salt, because these numbers are not, strictly speaking, statistically different from one another, but there's some evidence that, okay, I'm gonna wrap it up quickly. Conclusion, I'm gonna leave it here, and let's open up the floor for discussion. Thank you so much.
Thank you for a really nice presentation, and also bring in a little bit side of the objective side of mental health. I recently had a debate about mental health and well-being. Can you maybe give me an idea, how do you structure, where do you fit mental health into the whole concept of well-being?
Should I respond there? Yeah, I can take this question. So, disclaimer, I'm not really a well-being researcher to begin with. Like, this is the first, I'm starting to get interested in mental health, but I'm mostly a labor economist by training. Where would I put mental health and well-being in relationship with one another? I don't think I'm the right person to ask this question. But if, I have to give my 2 cents about the issue, I think that mental health is a determinant of well-being. So it's somehow, if you want, is the approach of Andrew Clark and the origin of happiness whole story. So you can see a mental health as one of the main ingredients that you want to put in a regression where you're looking at the determinants of life satisfaction over a person's life. But you can also, how much then does it matter? I think it depends on individual, and you can take other approaches like the one of Dan Benjamin and co-authors that are trying to understand what determines a good life by asking individuals, like, what do you think is a good life for you? So its relative importance might change depending on individual characteristics, I think. Good to know. Yeah.
So, okay, so thank you for your presentation. I just wondering if it's possible for you to also include the new approach, which is epigenetic, because in this case, there is a strong determinism, and finally, there is nothing to do. And if it's possible to have some data, I'm not sure, and how it's possible to include that, and finally, how to deal with this.
Thank you. One quick framing thing and then a more substantive thing. So my understanding is that polygenic risk scores are generally an underestimate of the true effect from your genes to whichever behavioral outcome. So just in terms of framing, you're really identifying a lower bound on the effect. And that might be useful if my understanding is correct. The more substantive bit is, so if men weren't treated, then the natural specification would be a difference not only between women of different ages, but also comparing to men. You sort of implicitly do this in a placebo test, but doing it in the identification strategy would give you roughly twice the power. And so that would be nice. You get more stars. So yeah, that's.
Okay, and then Irina, we can discuss later on. Okay, so first point about epigenetics. Yeah, you're absolutely right. We're ignoring any epigenetic effects. So for those who are not necessarily familiar with this, epigenetics are modification to gene expression that are somewhat linked to environmental exposure. So an environmental exposure can trigger stress, and this stress can trigger some modifications in the structures that wraps your DNA, which may lead in turn to some genes, bad genes activating or deactivating themselves, and illnesses and so on and so forth. So nice thing about UKHLS, there are also epigenetic data. Unfortunately, the main problem with epigenetics right now is that the sample sizes are very, very small, because only 1,000 individuals in the whole UKHLS have both genetic and epigenetic information. And as soon as you start restricting by age for this particular reform, then you end up with 100 people at most. And that's, so it's an issue of power, I would say, for now, but it's a very interesting question per se. And we're doing a lot of work on epigenetics with Conchita and Anthony at the University of Luxembourg. So it's exciting work in general, I think. And as for Casper's point, I'm a bit torn when you say that this is a lower bound, because it is in a way, because there's older literature on genetic heritability that says that heritability of traits is somewhere between 50%. So like the portion of a variation of a trait that is due to genes is somewhere around 50%. So that we're underestimating the portion that is due to them. At the same time, genome-wide association studies are association studies. So they're not causal direct effects. So we're not just picking up the direct genetic effect, but also the premia or penalties that are the society attributes to those genes. And there's some work being done on within family GWASs that's very interesting, and we can talk about it later. But my time is up, and thank you so much for listening to me. Looking forward.